Webinar are two people. First of all, we have Raf Meersman, the CEO of Comsoft, who is sitting next to me. He will be demonstrating the software later on. My name is Luc De Heijn. I'm Business Development Engineer for the FiberPlanIT software. And today's webinar will have the following content. Now, just to be sure, I've sent a message on the chat window. Is everyone able to hear us? If you are, then please mention something in the chat, and we will be sure that everyone is okay with audio. Now, the schedule for today is, first of all, a short introduction on what is FiberPlanIT, what can you do with it, and how do we use it, and also a little bit more information on the company of Comsoft. And then we will go on to the first topic of today, strategic planning for FTTx. Also a short introduction, and then also a detailed demonstration of the FiberPlanIT simulator tool. After the strategic planning, we go to network design for FTTx, and that will be a demonstration of the FiberPlanIT designer tool. At the end of the webinar, there is time for questions and answers. So we are kindly inviting you to ask questions using the chat window during the webinar, so we can respond to them at the end of the webinar. The duration is about 1 hour. Again, please, if you have any questions or something is not clear to you, don't hesitate to use the GoToWebinar question window. After the webinar, I will also send you all an email to schedule a call with us to discuss your own project or your own challenges with respect to FTTH planning and design, and you will have the option to design your own area using the FiberPlanIT software. Now, without further hesitations, let's continue, and I'll give the word to the CEO of Comsoft, Raf Meersman.
Thank you, Luc, for your introduction, and welcome everyone to our FiberPlanIT webinar. First, let me give you a very brief introduction about our company. Comsoft is a software company founded in '98, so we are already in the market for quite some time. And we have been founded as a spin-off from the University of Ghent. Our basic focus has always been on telecom networks and network planning, and we have developed several software packages in the past related to these topics, and obviously FiberPlanIT is the one we are talking about today. We are a Belgian company, but we have customers around the world in more than 20 countries, and looking at the activities of our customers related to FiberPlanIT, we actually have our customers having planned more than 15 million homes worldwide already. So this is, I think, a very nice set of references. So the solution is already very proven in the market. Here you see also a couple of names from different customers, including some operators, consultants who are using the software for their own projects and services, as well as equipment vendors, and also some construction companies who are doing detailed design for operators. So let's now look at what FiberPlanIT exactly is and what it can do. So in essence, FiberPlanIT is a GIS-based optimization engine for FTTx networks. So there are a couple of important things here. First of all, we are calculating on the basis of GIS data. This is important because that will give us a good accuracy. And secondly, it's about optimization and optimizing the design for the fiber access network that we want to plan. So how does it work? Well, as an input to FiberPlanIT, you need to specify GIS data, and you see an example here with typical inputs that is required is the street topology and points, geographical locations of your end customers, so that we know where the fiber needs to go. And apart from GIS data, you also have an interface, which we will show in the demo in all detail, where you can specify your design rules for your fiber network, including specification of cable granularities, splitters in case of PON, etc. Given these two inputs, you can launch a calculation, and FiberPlanIT will give you an automated and optimized design for this area according to your rules. This can be visualized on a map so that you can see what has been calculated, and you also get a full detailed bill of material, including a cost overview of the whole calculation. Now, where does this functionality fit into the overall planning and design process of a fiber network? Well, this is a possible process end-to-end of the whole fiber rollout. And as a first step, we identify a phase called strategic planning. This is where the big decisions are made, where to go with your network, how the architecture should look like, etc. Important activity here is also the business case for this fiber network. Once having made these decisions, you can set up the project in detail with an overruling project and process management activity, but then going into the detailed design, starting from an initial design for a selected area, taking this into the field, detailing it further, fine-tuning it according to the field inputs, and then finally constructing the network and updating the whole documentation of the network. This is an end-to-end process, and together with partners, we can deliver solutions for this whole process. But today, specifically for FiberPlanIT, we want to focus on the functionality of FiberPlanIT within this process, and that is situated in the strategic and in the initial design. So, and we are also talking here about two different software versions. First one is the simulator, which is in the strategic planning. The second one we call the designer, and this is more into the detailed design. And we will introduce these two platforms in more detail in the rest of the webinar. So let's first look at strategic planning. The questions we are handling in this phase are typically, what type of network are we intending to build? Are we going to construct this network? So which neighborhoods to deploy and which maybe not, given the economic feasibility of such a network in different areas. And another big question is when. So whenever you decide on a coverage, you probably can still be faced with a multi-year rollout, so it still makes sense then also to check which areas you should deploy first and which one only towards the end. Now, all of these questions are very important and also very challenging because you have to make the decisions in a short time frame, so the time to market is short. But on the other hand, you also need accurate figures for deciding these things. And this big challenge is something where the FiberPlanIT simulator offers a unique solution. So let's now look at the tool itself, how it works, and how it can support these strategic questions. Let me switch to or launch the FiberPlanIT simulator. So it's a standalone application. It can be integrated with GIS packages, but you can also run it in a standalone modus, in which case you can just launch the application, and you can start by selecting a workspace. For example, here I have an empty workspace to show you how easy it is to set up a whole calculation. So now I'm inside this empty workspace within the FiberPlanIT simulator, and the first thing I can do is to define my rules and material that I want to use for a calculation. So I can, for example, create a PON rule set, and in order to quickly populate this, I have access to a number of standard rule sets, which will allow me to very quickly have a rule set ready for the calculation. So now I selected a default PON rule set, you see I have here a selection of all customers to be treated as PON customers, so to be put on splitters. But I could switch to point-to-point simulations, etc. by selecting the right parameters. When you're in a PON, you can also specify the split ratios and how you want, where and how to deploy your splitters. And there are a number of important parameters. For example, here is a standard trench. To make a standard trench, you can specify here how much on average that will cost per meter. So for example, 20 euro per meter or $20. You can also choose your currency when you create your rule set. Another important parameter in the next panel is, for example, the number of fibers. So I could switch from 1 to 2 fibers just by specifying that parameter here. Another example of an interesting parameter is the capacity of a distribution point. Typically, distribution points could be intermediate points in the field, like a street cabinet. And I could, for example, specify that these cabinets could serve up to 60 homes, for example. And another parameter, just as an example to configure, is in the feeder layer or the top layer of our network, where we could ask the tool to select for us an optimized central office location, and where we can, for example, also specify to use a direct cable or a shared cable. This is with mid-span access or not. So a bit more technical, but all the explanations of these parameters are also within the user manual. So whenever you use the tool, you can look what configuration is according to your IDs. So this is an example of a rule set we just created, and the next input or the other input is on the GIS data. So we can define an area, and I can also give it the name. For example, let's create a new area that we call Ghent. And to define the area now, we need to select the input GIS file that will define our demand points, our street center lines, and optionally some extra things like poles in case we are going for overhead deployment, or existing pipes if there are ducts we can reuse, or for example if the central office is already available and reusable from the past. Now, just one quick remark. People who say they doubt if they have good GIS data available for their area, just one tip to check is you could always visit this website, OpenStreetMap. This is actually freely downloadable GIS data. You can search for your own area. So even, for example, let's say we go for the center of Miami now, and there you see, in fact, all the GIS maps which are generated by the crowd, by the users, and you can here directly export that, and then with some processing that we can also guide you with, you can use this input, for example, as the street map for your FiberPlanIT calculation. So whenever you are, let me see where I was. So whenever you are inside the area creation and you have prepared your data, well then you can browse to the files locally on your PC. And I have some example shape files or Excel files even that define, for example, the demand points or the buildings to be connected. And I also have a file here which are the street center lines. This could be, for example, an OpenStreetMap layer. And the optional layers, I won't use them now, but you can add them. And for a calculation of the simulator, I can also add, for example, a time frame, let's say 10 years, and an expected adoption, for example, 50% adoption on a point-to-point with a monthly ARPU, and another adoption for PON connections with another ARPU, whatever you want to use in your business case, let's say. And then I can create the area. creating the area will combine all our input GIS data into a FiberPlanIT area. So then I get this frame where I can see the parameters, I can see some statistics on the area, including a check whether everything is according to the input we require, and you see a little screenshot on the area. And then I can start my first calculation. So I give it a name, I select my rule set, my area, and I launch the calculation. And now the FiberPlanIT will look at your configuration of rules, will look at your GIS area, and start calculating the network design for your area. This is now an area of about 840 living units, and it takes, locally here on my standard laptop, it takes about 15 to 20 seconds normally, depending also on the settings of the battery usage and the CPU. And once it's done, I see a result in my table, which gives me immediately a view on what is my calculated cost per home passed, what is the additional cost to activate a home, what is the total expected investment for this network, and also based on the expected adoptions and ARPUs, what could be your revenue over a 10-year time frame. But this is only just some first high-level view, because for every calculation you can also go into the map. So I can directly open the result of the calculation on a map, where I will see how exactly this calculation has been done and what kind of network is proposed by the tool. So I can go and inspect here what exactly has been proposed as a network design for the area. This gives you a lot of input, whether your choices are in line with your expectations concerning the real network design. You can also even watch or look at this inside Google Earth, which is just another representation of the same, but given that you also have there the satellite pictures, it's actually very nice to also check whether, for example, your input data is of good quality, because you can immediately also see whether your points are well aligned with the buildings and where your cables are going through the streets. That's a geographical output, but equally important when it comes to the simulator is obviously the bill of material. So the bill of material is just an Excel work file where on the first sheet I can see, okay, the input and the results overall of the cost calculation. And I can also see some first basic breakdown of cost into homes passed, homes activated costs, and into the different, let's say, stages of my network. In the second sheet, I actually can see the whole bill of material, where I can see exactly how many meters of trenching are calculated for this network times my unit cost, how many homes are to be connected, how many splitters I need, how many cables, ducts, etc. So all the components are listed here, and the calculated volume is multiplied with the specified unit cost in the rule set and gives us a full detailed overview of components and costs. And we can also play around to simulate with different groupings and different unit costs, or we can also consult a bill of material and an estimated cost on a DP level or distribution level, which will give us some insight on the cost of local parts of the area. So that is already a very interesting output. But of course, one of the questions we had before was actually to say, okay, this is now one rule set, but maybe we don't know yet whether we will do 1 or 2 fibers per home, or we may not know whether we want to go for a more centralized or decentralized splitter scheme, etc. Now this is very easy because, of course, here I can quickly generate a new rule set and just, for example, start from my current one and start changing a couple of parameters to create a number of alternative rule sets, and then apply them to the same area to see the impact of this. And I have another workspace where I already did this. So you see in this workspace different rules, like switching to one fiber per home, going to centralized POMs, and then some kind of an optimized POM based on a lot of simulations, and where a lot of the parameter settings are more advanced and more fine-tuned in order to be optimal for our area. And then just by applying all the rule sets on our area, we can calculate all these results and immediately see what such a choice does with our overall costs. And for example, I could also quickly copy-paste that into Excel and make this kind of analysis where you see what is the effect of going from 2 to 1 fibers, or how much more is it for a POM centralized or point-to-point configuration, and what is the difference of my first POM with 2 fibers versus my optimized POM calculation, also with 2 fibers but with optimized rule sets, which, by the way, in this case is around 80,000 euro, so a very significant amount, or 6% in this case, that we were able to lower on the overall cost. So that is already one typical usage that is very useful to quickly compare technical scenarios. Another one on the simulator that we want to very briefly introduce, but where a lot of things are possible, is on the business side or the geomarketing side. So in another workspace here, I prepared an area with more than 23,000 living units, and you see the area here. So it's based again on some GIS input data, but this time I also added a geomarketing file. And this geomarketing file, if I visualize it here, actually what I had there is that I identified some neighborhoods and I associated high or low potential of becoming a fiber customer, fiber to the home customer, when I deploy the area there. And of course there is more detail behind what is the typical maximum take rate in a high and a low potential area. So that is things you can do, or sometimes you can even do it on an address level to specify for each individual address the potential based, for example, on statistics of is it a young family with children or elderly people. This could be, if this data is available, based on some marketing analysis, you could specify such input data and then use it in the analysis. So having added this geomarketing data that is much more refined and differentiate between different neighborhoods, we can do a simulation with this geomarketing data. And if I go to the results for this complete area of such a calculation and the map, the interesting thing is that for this complete area, what you get with some adjustment of the visualization of our output, it's some kind of a heat map. So for the total area now, you actually see on a DP level, so on a, let's say, neighborhood level, how cheap it is to deploy a fiber network. And this is somewhat linked to density. So the more dense, you can see what is the relative difference between the most dense areas here in the north and the least dense areas here to the west side. But cost is only one thing, and the importance of the geomarketing data becomes important when you, for example, visualize the heat map that is not linked to cost, but for example linked to break-even time. So locally you can look what is the cost to deploy fiber to a certain set of homes, but then if you also know their potential of becoming a customer and generating your revenues, you can actually visualize that in an interesting business heat map where, for example, you could say the low potential here makes it become less interesting, and now little bit more expensive area to the south with a high potential actually becomes more interesting from a business perspective. And this will, in the end, allow you to really focus on the most interesting areas first and maximize the return on investment for your fiber project. So this concludes the overview of FiberPlanIT Simulator. And then we return to the presentation. So we quickly shown you two typical usages of the simulator. And what we are promising with FiberPlanIT is that we can make this strategic planning smart, fast, and easy. And why do we say that? Well, as we've shown, we say we can make it smart because we can actually calculate reliable and transparent cost and revenue figures on a complete area based on basic GIS input data that is available for a lot of areas. It's also very fast. So I've shown a real calculation on an area of about 1,000, but for example, the city or an area of 23,000, you can calculate within an hour. And even we've done national calculations on a whole country with parallel calculations ongoing, and so that in a couple of days you could calculate a heat map for a whole country. And it's also very easy because of the easy configuration of parameters. You actually don't need to be a technical expert to generate these results. You only need some assistance to pick the right configuration by a technical engineer, and then any business user can do the trick. All of this is quite unique in this stage of the process, because you have alternative methods typically used. For example, Excel files, spreadsheet models, which will give you also these large-scale quick results, but have not the accuracy of what we have been demonstrating here. And then you also could do some kind of a detailed design, but then you can reach a high accuracy of a cost estimation. But of course, this in an initial stage of the project is not scalable to do on a large area and for many scenarios. So often this is just not an option at this stage. And it's thanks to FiberPlanIT that all of this, so the accuracy linked to speed and scalability, and even the flexibility of configuring your rules, is very unique to support you in this stage of your fiber project. So that is about the FiberPlanIT simulator. And then the second part of our webinar, we would like to introduce you also to our FiberPlanIT Designer solution. So as we said before in the process view, the Designer is more looking into the support of an initial and detailed network design for a certain area. So we made our choices. We know now where we want to deploy first. We know which rules we want to adopt. And now it's about choosing which homes really to cluster around a flexibility point, which routes to take for cables and ducts, where to locate these flexibility points, etc. And this is where the designer can assist an engineer in making these decisions. And the challenge is really on, you can do this in a cost-optimized way based on a map, but you also need to consider the field conditions, and as such, you need to make your plan field-proof. But in a lot of cases, we see if you make it field-proof, optimization is not considered. And this is one of the things where the designer of FiberPlanIT tries to give an answer to combine these two aspects of the network design phase. So why is cost optimized important? Well, if you consider a certain area, and you see it here with a street map and identification of the homes to be connected, and you would give it to 3 different planners and ask them to create a plan based on the same specifications of rules, for sure you will get 3 different outcomes. Each designer will have a different plan, and you wouldn't be able to say one is better than the other. They will all be feasible and possible. But when you actually would calculate the costs of each of these plans, and this is not even an extreme example, but just a realistic example, you see easily a difference between 4 and 8%. And if you give the next area to the same 3 planners, maybe there's another one who will now have the cheapest. So it's not not related to the quality of the designer. It's more just not the ability to check out all the possible scenarios. And that's where the software comes in handy, that this software can evaluate all these scenarios and always pick the cheapest one. And the potential of these savings is huge, as 5, 6, 7, 8% on a deployment of fiber really goes into the high numbers, as we all know the deployment costs are typically significant for this kind of networks. But why is field proofness important? Well, you can calculate an optimized plan which says, for example, as here, that your flexibility point should be placed in this specific location. But what if there's an obstruction there, or you can't put it there because you don't get a permit in that street? Well, then based on field survey and redlining in this case, you may want to make a number of changes. Also, for example, your central office can be optimally placed, but maybe it's not feasible to put it there. So all of these changes, what is important is you should be able to recalculate and re-optimize a network plan given these forced changes, so that you can still do as optimal as possible given the constraints coming from the field. And this is what the FiberPlanIT designer can do, and we will now demonstrate that in a live demo. The FiberPlanIT designer is a variation. It's different from the simulator in the way that in this case we really want to work on the GIS data and be very interactive. That's why the FiberPlanIT designer is almost always integrated with the GIS platform itself. I am now demonstrating what we call standalone designer, which integrates with QGIS. QGIS is just an open source, freely available GIS platform. But actually the designer also comes in integrations with many other GIS platforms and network inventory systems of different vendors. So whenever you have such a platform, feel free to inform whether we have already an integration or whether we know that an integration is possible with your own system. But you can also do a design perfectly from within this Quantum GIS platform. There's no problem to start generating your optimized plan here. So what I did is, well, I have a toolbar here within Quantum GIS that allows me to launch FiberPlanIT calculations or processing functions. And I also prepared an area which basically started from the same data that we used for the simulator, like street maps and address points. Now, similar to the simulator, I can access the rule set, and where in the simulator we would play with the configurations to simulate various scenarios. In this case, it's more about configuring the rules according to what was decided as the design rules and as the architecture. But basically, the settings are very similar in the designer and can also be easily ported from the simulator to the design. So similar parameters, and the configuration is also very similar. On the other hand, we have our GIS data, and you see the street maps and the address points. Now, FiberPlanIT offers a number of help functions, for example, to create possible trenches. If you use that function, FiberPlanIT will generate a possible trench network on left and right side of every street automatically, and will use for that also the attributes that you may have available or that you can insert on a street level. For example, for this street, we have specified that the width is only 2 meters, that it's a very narrow street, and then our automatically generated trenches are considering that width and are using that to produce a candidate trench. Now, we are not saying this will be a use trench, we are just generating the candidates at this stage. Similarly, we can automatically create dropped trenches or connections from our demand points or buildings to these possible trenches. And doing so will generate us a layer that connects all our homes with these possible trenches, so we can make a connection between our demand points and the rest of the network. Then another function here is create candidate crossings, which will insert in our map a lot of possible places where it could be interesting to cross the street. Obviously, it makes no sense to cross the street very often, and the cost optimization will take care of that. But we are now just offering a lot of options. And this is also quite unique for FiberPlanIT as opposed to other tools, because we are asking the algorithms and the tools to decide which crossing is the best, rather than just drawing our own limited set of crossings, which will then exclude a lot of maybe more optimal crossing locations. What is also important in this is that you can still edit all of these automatically generated elements. So for example, on a crossing level, you can select the whole set of crossings in the street, for example, and you could, for example, delete them if you say it's not possible to cross a street in this part of the street. Or you can go into the file itself and you can see the selection, and via a subtype attribute you could actually make it a special crossing, for example, based on drilling. So if I update this value by saying these selections, so I could say update the 25 selected features and make subtype drilling. Okay. So then in the street I'm indicating that anytime I would like to cross, I need to make a directed drilling, and this could be then more expensive than in another street and will be taken into account in the optimization. By the way, where the unit cost of drilling needs to be rule set. So if I return briefly to the rule set, you can see here in the first panel we have this standard trench where we can also say a standard crossing cost, but I can also add custom subtypes where I can reuse the same subtype naming, and where I could specify that it is, for example, much more expensive per meter or with a fixed cost to cross the street when the subtype is this. Similarly, the part or the side of the street could be indicated that you have subtypes like expensive pavements or grass, which is much more cheaper, and specify different unit cost per meter, so that all of this is taken into account, not only for the bill of material, that you know how many meters in which subtype will have to be trenched, but also in the optimization to decide by the tool whether it will use a shorter route over a more expensive subtype, or whether it will use a longer route over the cheapest subtype. This is then covered by the algorithm. So this is the input data preparation, and once we have done all these preparations, we can start calculating. So the calculation is very similar. So we have fixed our rules, we have prepared our input data, and I can then launch the FiberPlanIT designer, which will read again all the input data, read your configuration, and then start calculating the whole network. Again, this is now an area of some 500 or something connections, and takes only a few seconds to calculate, but it scales up to typical POP sizes, even with 20 to 50,000 homes, in which case, depending on your rule set, and the power of your PC, you may need between maybe 10 minutes and half an hour or maximum 1 hour. And then you get an output which shows you your area with polygons automatically created that group all your homes around one distribution point. It shows you an optimal location for your central office, and the blue line, that is the feeder cable that connects all these distribution points to your central office. So also in this output, you can select any layer here that was generated by FiberPlanIT, and you can go and inspect, for example here, that it's a 12 fiber cable that is chosen to connect this cable. And for example here, you will actually see there's a 12 and a 48 fiber cable that is needed on this part of the network in order to connect all the components in the network. So this is an initial design, and also we can access a similar bill of material so that we can see the total volumes of what has been calculated, very similar to the simulator, with the total length of trenches, etc. But now what we can also do is, in this design, we can actually, for example, lock our central office. We can lock, if we want, our distribution points. And by doing so, we are actually saying, okay, these locations and these groups for the future calculations should be fixed on their locations that they are placed now. But like we said before, with field proof, it could well be that the central office location is not really feasible from this place. So then we could just pick up this locked place and shift it, for example, to a place where we know we can host this central office. And similarly for distribution points, we could say, yes, we know this one in the distribution point level. It's not possible there, but needs to be put on the street corner. This could be based on knowledge of the field or field survey, but there's also an interesting feature here, because we could actually click on the location that was chosen by FiberPlanIT initially and automatically be taken to this location inside Google Earth, and actually go and see on Google Street View, if it's available for your area, whether that location, which is here, is feasible. And okay, here we have a window, which I think is not very ideal if we need to put a cabinet there. So we can also verify here whether, for example, indeed the corner here is a better alternative, and then return to our map here and just shift the distribution point to this new location. So making such changes is very easy, and we are now imposing these different locations, and then we can launch a new calculation, saving our changes, and we will see, after recalculating this area, how the network design is optimized again, given these new locations, and everything is recalculated, so we have no errors, there are no fibers missing, and the cable routes are re-optimized given this new input. And also the bill of material is recalculated, so we can also compare our new calculated cost with our previous cost, so that we also know what our changes have done with our overall budget for the network. And for example, if you have multiple central office candidate locations, you can actually shift them to each candidate location, quickly recalculate, and you will see the best location from a cost perspective very quickly. So you see now our feeder cable here going to this new location on the corner, and you also see everything actually originates now for the feeder from this northern location. And to see what this has done with my actual costs and the calculation, I can access the FiberPlanIT State Manager. this state manager tells me that my current state, so my current calculation is actually 407,000 euro as a basis, as a total sum of the costs. And you can actually look at your other calculations and see how their total cost was. So, for example, there's another full underground on 402, and in fact, the previous calculation with the optimized location was in this case 404,490 euro. So the difference in this case is about 1,000 euro, which is very limited, and actually we can go and check each bill of material and compare them to see where the differences are. So this allows you to really see any change in the network, what it does with your overall cost. And if you don't like change, you can also always return to any previous state or save some intermediate state like the current one. We could say this is a design during webinar and save that so that any time later you can return to this design if your changes since then you would like to revoke them. So this gives a view on some of the capabilities of the designer. Only what I also want to show very quickly and briefly is that what I'm doing now is some kind of a greenfield underground network, but in fact I can very quickly for the same area change that into a aerial or overhead network. The only thing I need to do for that is define the locations of my poles. So this could be here in a separate file. I could just start creating pole locations. If I know them, I can just click on the map where the pole locations would be, or I could import them from another GIS system where they are documented. Or even if I don't have pole locations, there are help functions by the FiberPlanIT designer, for example, to create automatically locations of candidate poles, then automatically create connections between these poles, and automatically create aerial drop connections. So just to shorten the time, I'll show you a prepared input area for such an aerial design. So input full aerial load. And here you see for the same area, actually the processed input ready for an aerial network calculation. So you see the location of the poles, which have been imported from some system, and with the help functions of creating aerial connections and drops, in a 5 minutes time, I actually can turn that initial underground network into a network that is ready for a calculation for an overhead network. And on the rule set, this also has some implications, because now I also will have to specify the different types of cables, because some part of the cables could be aerial, but others could be still underground. So for example, on the distribution level, you can specify the costs and the installation costs for an aerial cable of a certain type. And let me just take a shortcut here. So again, returning to the Euro and taking an example rule set for aerial networks. Well, you see in an advanced configuration, you can also add some parameters like a cutoff distance for clusters, so that you have a maximum distribution cable length. And very important here is per layer you can specify whether this aerial deployment is allowed or not. This means, for example, separately for the feeder, I could say feeder cable does not go overhead, feeder cable goes underground, or I can allow it for the feeder cable as well. So with this rule set and such an input prepared, I can again launch the calculation, and now FiberPlanIT will again do the same, only given that we configured it for the aerial and that we prepared the input that is required to produce this aerial design, it will look at the costs and choose the most optimal way, which in this case is expected to be a full aerial cable network as well. So it's writing out the output and refreshing the view. A lot of, yeah, that's also important to mention. The designer will produce a lot of different layers automatically that document the whole network, and this is important because this will give you a lot of data that you can automatically import into your inventory system as well. Now, it seems my area was not processed correctly because it didn't consider the poles. Just let me open up a previous design. So initial full aerial design that was created earlier when the settings were correct, because I must have missed something in the process now, typical for a live demo. Anyway, if everything goes well with the aerial design, what you end up with is quite similar, but still, actually, when you look at the details, you actually also see now the homes are connected via a drop cable. So I also have a specific view for aerial networks that allows me to really see how the aerial network is built up. And you see all the homes connected to a pole. You see the drop cables. So if I click on a cable that connects a home to a pole, you also see it's an aerial cable. Same with the distribution cable that goes from pole to pole. You see, in this case, it's an aerial cable of 24 fibers going from our closure on one pole and visiting all the drop points on each pole. So just by adjusting the input and the rules, you can calculate both aerial and underground network, and even if a certain street has no poles, it will automatically mix both types of networks, only requiring a little bit extra configurations on the rules. So this is concluding our demonstration of the FiberPlanIT designer. And what we've shown is the automated and optimized initial design, and then also the fine-tuning according to the field input. And again, as before, we are trying to make the network design smart, fast, and easy, which in this case is reflected by the fact that in general we see cases where 4 to 8% is easily achieved as opposed to manual design when it comes to the overall deployment cost of the design. It also goes very fast, so the design team can focus on the real big issues and not spend its time drawing lines. Still it depends on the way they did it before and the quality you want to achieve, so how many fine-tunings you do, but the savings are easily 2 to 10 times in efficiency. And also very easy, and this is also illustrated, for example, by our users producing an initial design for their area, even starting by learning the tool, and within one day finishing with the first design for an area of about 1,500 buildings. And the uniqueness of this solution lies in the fact that we are offering this optimization, while other tools may say they also do this, or to some extent, well, most of the time they are more into automation and not really optimizing the choices. And one of the best points to view that is what you can do with all these candidate crossing locations and letting a tool choose. Well, that is real optimization instead of automatically routing a cable through a limited set of possible trenches. On the other hand, there are some tools who are also focusing on the optimization power, but up to now we haven't seen any of those really capable of adjusting to the field conditions very easily and flexibly. And that is where FiberPlanIT offers a unique combination. So as a conclusion, we have illustrated that FiberPlanIT makes planning and design of FTTH networks smart, fast, and easy, which is our promise to all our customers. This is delivering for you as a user with the simulator an optimized strategical plan, and as a result a maximum return on investment for your project, while the designer will lower the costs of the overall design while increasing the quality and making sure the plan is feasible. So all of these values are brought to our customers and have been proven already in more than 50 projects worldwide with more than 15 million homes planned, and have shown significant savings in costs, significant increases in revenues of the business case, and a significant increase in the quality of the overall process. Thank you very much for your attention, and I hand over to Luc, who has a couple of more things to say on this.
Well, thank you, Raf, for the demonstration of the FiberPlanIT software. I hope everyone who was watching did understand the majority of what he was talking about. But if you have a few questions, don't hesitate to still ask them using the question window. Now, after the webinar, I will also send you an email so you can access the recording of this webinar, so you can share it with your colleagues. You can also schedule a 30-minute call with one of the FiberPlanIT colleagues to discuss and review your project together. We have a huge amount of experience and expertise in FTTH planning and design. You are free to use these 30 minutes as you want, but I'm sure that we can assist you with your more urgent questions. And I will also invite you to profit from a special package, which is called the Starters Package for the FiberPlanIT Designer. What it does, well, for 1,500 euros, you will be able to design 1,500 buildings using the FiberPlanIT Designer. And typically, within a day, you can realize the installation, the training, and even the design of these 1,500 buildings. So you will get full access to the tool, full access to tutorial videos online, and on top of that, you will get 2 hours of free assistance from a FiberPlanIT expert. So if you're interested in that, please see the follow-up email, or you can always contact us via the link of fiberplanit.com/contact. So I will head over to the question window and answer any of these questions. One of the first questions is about the price of FiberPlanIT. We know that the designer can now be purchased for 1,500 euro, but after that, Raf, how does the price evolve? Does it grow with the company, or is it? How do you do that?
Well, in fact, we offer the software based on 2 licensing schemes. The first one is intended for smaller projects, or in order to get started without a big investment. And so this type of areas is linked to the size of the area, and where you have the starting package with 1,500 buildings. In fact, you could purchase a license for any type of area, and we will just look at the number of buildings. So it's important to note that it's buildings, so multi-dwelling units will also be counted as one. And based on that size, you can get an offer for an area license that will allow you to design that area of that size. And the order of magnitude that you see there, well, it's a special offer, but let's say the order of magnitude is more or less the same when you start with significant areas, and when you really go into high volumes, there is a volume discount on that. And I would say when you are looking towards the design of more than 100,000 buildings in the end, then the second option is probably more interesting, and that is the seat license. That is just linked to the number of concurrent planners on the system. Anyway, if you have a specific question on pricing, just feel free to reach out to us with your specific question, and we can always give you a dedicated offer for that case.
Right, so it's good to know that the software price grows as you design more buildings. A second question is about the fact of how does FiberPlanIT handle or manage multi-dwelling units or flats?
Mm-hmm. Yeah, it's a very good question because it's obviously of a very high importance. So basically on the input side, we ask the user to identify the multi-dwelling unit by specifying as a demand point the entry of the building. So if a multi-dwelling unit, you would enter it in one place, you would just have one demand point for the multi-dwelling unit, and then there's an attribute that allows you to specify inside that building how many living units there are. This is on the inputs for the GIS. Based on that, FiberPlanIT, when calculating the outside plan part, will consider this amount and will apply the rules specific for a multi-dwelling unit. For example, if you say, as of 7 or more apartments, I want to put splitters in the basement, it will look at these attributes and make sure that splitters are placed in the basement of such buildings in your design. And then, of course, all the fibers coming to that building will be adjusted accordingly. So this avoids a lot of problems and errors possibly in the design, while delivering a dedicated solution for the part of the multi-dwelling unit. On the inside of the buildings, currently FiberPlanIT there does not do any optimization. You can get cost estimations for the costs of what's needed inside the multi-dwelling unit, but to do a detailed modeling of the network there, there we have partners who have tools to do that, so we can operate together with our partners. And also, for the moment, there's no real data available to do a lot of automatic calculations, so this remains something that is, to a large extent, manual design work of in-house cabling.
Right, thank you. Now, Raf, how is FiberPlanIT installed at the customer? Is this a desktop or is it client-server based, or how do you do that?
First of all, the intention of FiberPlanIT is to make it possible to install in different ways. This also means it is indeed possible to install it just on your own PC, and that doesn't have to be a special PC, just a recent PC is fine. I would say the amount of RAM memory is one of the most important points in order to run the calculations. If you have 2 or 4 gigabytes, you're fine. More is nice if you go to the big area. So you can run it as a thick client, basically. But again, through partner systems, you can also deploy it in a virtual environment so that it's client-server based, or even cloud-based is possible via partners who are offering then also the interface to GIS via the cloud.
All right, thank you. You mentioned that FiberPlanIT works with shapefiles. Does FiberPlanIT also work with georeferenced CAD data, or some GPS points via an Excel or CSV format, or how can all that data be imported into FiberPlanIT?
Yes, we demonstrated with shapefiles, which is, I would say, the default format of GIS data where we can always work with. But we also support other formats, GML, and indeed, even like for demand points, you can just list them in an Excel file or a CSV file, as long as you specify separately the XY coordinate. When it comes to very specific formats like AutoCAD formats, DWG, that is not handled directly. But there are ways of converting that into formats that we can use, and we have a lot of experience with that from our customer base, because we do come across a lot of this type of inputs, so we can both assist in doing those transformations as well as in teaching how to do it easily. In that perspective, for example, a tool like FME can be very interesting to switch between all these different GIS formats. So basically, there is no big issue, given the fact that we've been using this in more than 50 projects. A lot of formats have already crossed the interface, and conversions are sometimes needed, but are feasible to make.
Okay, thank you, Raf. I see we do have a few more questions, but we are running out of time. Now, if you have any questions, please use the follow-up email that you will receive in a few hours to ask them and schedule a meeting with us. We're more than happy to assist and answer any question you might have about FiberPlanIT or any other FTTH planning or design issue. Thank you very much for your attention, and we hope to talk to you soon.
Thank you. Bye-bye.